everyone. My name is Stephen Weingartner, and today I'm going to be covering the topic of a single data platform for all your workloads. Just a brief bio about myself. I've been at Snowflake for only a few months, five or so months. My title is a senior solution engineer, and I've worked in the analytics space since the 1990s, so been around the block a couple times. Basically, this is the challenge a lot of organizations face. Basically, when they're trying to deliver data solutions, they're dealing with all sorts of complexity. There's so many different programming languages. Data can be very fragmented. You can have HR doing their own thing, finance doing their own thing, data scientists, data engineers doing their own thing. It can be difficult to transfer data between organizations. Even sharing within an organization can be difficult. Organizations, they get frustrated when it takes a while to deliver even reports, but certainly even machine learning AI can take a very long time to deliver. And lastly, organizations have headaches around heavy costs, inability to scale up, scale down, poor performance as well, which distracts the team, and they struggle with those issues. So recently on Reddit, there's a sub for data engineers, and someone came up with a little list of things for data engineers to learn in order to be pretty proficient at their job. And I just want to bring it up to show that this is a challenge, and this is why a lot of organizations really struggle to find someone who is a quote-unquote really good data engineer, because it's just a massive range of skills. There's a whole bunch of tech. What we're seeing here can be quite overwhelming for a lot of people to get into, and ultimately they're doing all this to try to get to the very tail end, which is where you can get your report in a tool like Tableau or Power BI, or for the data scientist to be able to build a prediction using some sort of tool to build a model. As some more background, as some challenges around data. So here's a typical way that organizations have been building data platforms for quite a while. You basically build your ETLs, you have a data warehouse, you have some sort of reporting tool, and then you're done. And what's happened with time is it's gotten a bit more complex. We have like cloud solutions, people have incorporated data lakes, you have CDC or streaming data, Spark to crunch big numbers. Within the organization, you get more data sources, so IoT data, AI, ML. You get different parts of the business, like the finance team went off and bought their own data warehouse, or HR has their own data mart. Multiple data scientists have multiple solutions. You could have different data engineers using different data lakes rather than a single data lake. And with time, it just gets more and more complex. You get integrations over the place, people going all over the place to get data, people in the business having to mess around getting data from one place to the other or manipulate themselves. So this is a problem that a lot of organizations face today, or at least they have an architecture where this is where they're going. And as a result, what happens is you kind of get everyone in a situation where they're not really working together. The data engineers have their own platform. The data scientists, they're doing their own things with the data lake and their own file formats and their own feeds of data. The BI team has some clean data in the data warehouse, but it's not everything, and they struggle to work together. So this is where Snowflake comes in. It's on the left-hand side the same data sources, and on the right-hand side all the same different ways to consume the data. And what Snowflake is a single platform that can run on all three clouds. I'm based in Australia. Within Australia, we run on either AWS or Azure. And the key thing is we can handle all these different workloads. We've been around for 9 years, so many people know of us as this data warehouse. We came out as this super high-speed data warehouse that was just so fast and so easy. It was really easy to migrate to that and whip out your reports and speed up your data warehouse and lower your costs. And quickly after that, people realized that our disk is so cheap, you can just stick in all the data you want. We have structures that can handle semi-structured data, so like JSON files, XML, Parquet files, and such. And therefore, Snowflake can also act as your data lake. And from there, you can also do your data engineering and set up the identical platform, and data scientists join in and use the shared data as well. The philosophies around Snowflake are that it's a single platform to handle all those workloads. It is a SaaS type of a solution. You don't need DBAs to do run and maintain. No one's applying any patches within your organization or up at 2 in the morning fixing problems. And we have a ton of security and governance features, and this applies to all of your data, really crucially important. And lastly, as I spoke before, we came out with this unlimited sort of way to performance and scale, and it applies across all these workloads, not just the data warehousing, but it applies to the data lake and data science and onwards. So I'll just kind of show one slide of the architecture of how it kind of hangs together. In the center, we have our what we call databases, which are kind of like our file type of system. It's totally separated out from our next ring out, which is compute. And basically, if you give us like a big file, what we do is we break it up in tiny little, what we call micro partitions, tiny little files that we store on the object storage of these cloud vendors, so AWS S3 or Azure Blob Storage. In that middle ring, spin up, spin down, turn on, turn off. It's all automated. They start and stop within a second. Basically, we're running all this compute on the VMs of the cloud provider. So, our warehouse is, basically an EC2 sort of instance that's always running hot, and it's just provided whenever you need it. Or when running on Azure, it'd be Azure VMs. And because this turns on, turns off pretty instantaneously, what we can do is just normally leave everything turned off, that you're only leveraging compute only when you need it, and when you're done, you give the compute back again, and you stop paying. The final outer layer is our cloud kind of SaaS sort of services type of layer, and this is where when you want to understand your table structures, create tables, play with your roles and security, connect to an API or whatever, then you leverage that layer. So I'm going to cover just briefly today how Snowflake works for several of these key use cases. Basically, for the data lake, I have a lot of information on this slide. Don't want to cover it all, but there's a couple of key points I'd like to get to. Is that on the left-hand side, we're able to bring in data, all sorts of different data. You can use Snowpipe to automatically suck in data from an existing data lake. So if you've already figured out how to land data into AWS S3 or Azure storage, you can just use that to automatically suck the data into Snowflake. We have Kafka connectors where you can stream in real-time type of data, IoT type of data. On the lower left, I think is one of the more interesting ones, is we have support for semi-structured data. So you can just load in your JSON files just as they are. You don't have to parse them out, just load them in. And we have a SQL type of language that you'd be able to create views with, and basically your BI users are immediately able to use those JSON sort of files and query against it at really high speed. The data basically appears like a table. I'm not going to go through all the points here, but basically, we could spend a whole time just on the topic of the features of Snowflake that make it work as a data lake. Interesting enough, if you look at Gartner Peer Insights, Snowflake is extremely favored by users as being just a really easy place to be your data lake. In addition to being kind of low cost for disk and easy to interact, because you can just use SQL to interact with all your data, it has just a whole bunch of capabilities that allow it to work together within the bigger picture. And I think one of the key things, I think the most important thing about Snowflake when it comes to the uses the data lake is at the very bottom, where it's secured and governed access to all data. We have a whole bunch of security and governance controls as to how people will access this data. And this is something that doesn't exist with a lot of other tools. Okay, so how do we use Snowflake for data engineering? I'm a big fan of just keeping everything as simple as possible whenever possible, and cutting out risk and time and challenges and headaches. So, in contrast to learning every single language and actually using every single language when you want to move a piece of data from one place to the other, I personally have a view of when you can use something simple. So here's a screen snapshot of using Fivetran, and it's just kind of where you type in the username, password sort of thing for your source, if it's Salesforce or Workday or an Oracle database. Here's like a CDC sort of connection that you're going to straight load it into Snowflake. And basically what a tool like Fivetran does is they have like 170 adapters, and it just kind of near real time synchronizes all the data from all those upstream systems straight into Snowflake. And it's just kind of an idiot-proof type of tool. Another popular tool out there that people are using is Snowflake is Matillion. And it's a fairly newer type of ETL tool. It's cloud native, and it's kind of more of a drag and drop sort of interface to build your data flows. A lot of organizations are using this to quickly build their integrations and their transformations within Snowflake. This pushes everything down. This really understands how Snowflake works, and it's able to work well within the tool at high speed. dbt is really popular. dbt is designed for people who are familiar with SQL, and it's deeply integrated with Git, and it can also churn out its own documentation. So it's kind of a lightweight, very data engineering friendly, very industrial sort of method of building and maintaining transformations inside of Snowflake. And it's also an extremely popular tool that's very often paired up with Snowflake. Interesting enough, this is also very often paired up with Fivetran. So Fivetran will land your data into Snowflake. And then there's a whole bunch of pre-built dbt jobs that you can just grab, and they will, for example, pre-build a star schema against all sorts of systems, things like Salesforce. So this is a slide that covers that, what I mentioned before around JSON type of data. So you can bring in data like JSON and just immediately start using it. You don't have to parse it out with your ETL tools, or try to figure out what every single structure within a structure is for those JSON files. It's you almost kind of have to see the demo to see how well this thing works, but it's very efficient for helping organizations take all their JSON data from all these REST APIs from all their SaaS applications and just immediately use this data in downstream. We have serverless tasks. So an example is Snowpipe, where you could just read against your files that are landing on S3. We have connectors to Kafka. We have tasks and streams within Snowflake that can process data. And basically this just means all these can just kind of run 24/7. You don't have to worry about how big it is. It'll just auto scale to whatever you need. And it just is effectively shut off or all the way scaled down to always minimize your spend, and it only has to scale up when needed. Schema detection is a pretty new feature, and this is where you can just kind of load some files in, and Snowflake will figure out what's the structure of these and then create a table with the proper columns that match up with this. We have a bit of a roadmap on this topic as well. And data engineers are also kind of keen to be able to share the data out with applications. So you can leverage SQL APIs and expose Snowflake out via a REST API, and then applications just can tap into this data via this API and effectively just pass a SQL statement and then get whatever data they need back. Snowpark is a pretty new feature of Snowflake, and what it allows organizations to do is to use the data engineers and data scientists can use their language of choice. They can use like Scala. We have Java and Python coming up quite soon, where they can code in the language of choice. And then what happens is Snowflake will translate whatever they're doing basically into SQL statements. So basically, the data engineers and data scientists can be in like a Jupyter notebook and just code in whatever language they want. And just by importing in these Snowpark type libraries, then whenever they're doing something like a data frame, like I want to use this sort of data, then Snowflake translates, send it to SQL statements for selections and also inserting data back into Snowflake. So it's an easy way for you to use your language of choice when you want to interact with Snowflake. Java UDFs are basically your ability to upload Java jar files into Snowflake and run complex calculations and algorithms inside of Snowflake. So when you want to run, for example, if you have a predictive model from data science or natural language processing, you've created a jar file that can do that. Now you can basically pump all your information within Snowflake. If you have it in a table, you can run it through those functions or procedures that are leveraging that jar file, and then creating a whole other table. So kind of sky's the limit for now what you can do within Snowflake for manipulating your data. We're no longer limited by SQL. It's kind of whatever you want to code in a way. And again, so like similar to the data lake, so data engineers would leverage a lot of these same capabilities that make Snowflake quite popular as a data lake. And I've covered a lot of these points. Data sharing is a very interesting feature for Snowflake because we're all up in the cloud. It's easy just to share data from one place to the other. And this avoids a headache that organizations have around having FTP servers, which they have to worry about the security of these, and interfaces breaking, and some supplier didn't send one of the files, and how are you going to recover that? How are you going to rebuild your messed up data? So with Snowflake, it's just basically a matter of kind of clicking that you want to share a table with another organization, and vice versa. You can get data from them. You can kind of create these exchanges where you have a couple close corporate partners or other government partners that you're working with, and only you guys are sharing data together. Or you can do this external. You can grab, we have hundreds of really interesting data sets available on our public marketplace. And even each of those data sets can have dozens or hundreds of tables that someone else maintains the data. And this is really cool. I have a machine learning demo, and I use some data that Johns Hopkins University maintains. And it was so easy. Just click the button, grab the data, and every time I run my demo, my data has been refreshed for all this coronavirus and all this Google mobility related data. Every time I do my machine learning predictions, someone else did all the hard yards to make sure my data is up to date. And so that was one example where I used this COVID-19 data right there, but there's plenty of other data available for organizations. And this visualization here is showing which organizations are kind of using which data sets and how they've connected together. We're really growing in popularity. This hasn't been around for that long, but it's growing pretty quick. So Snowflake as a solution for data science, basically we handle both sorts of data scientists, both your citizen data scientists and also your more traditional data scientists that are using their code sort of interfaces, writing a whole bunch of languages and using frameworks and libraries. So for the citizen data scientist, we're very close partners with Dataiku, DataRobot, H2O.ai. Those three citizen data science tools have heavily modified their tools so that they can run basically inside of Snowflake. Their feature engineering and a lot of what they do actually runs inside of Snowflake. You don't have to suck the data out to have it run inside of those tools. But a lot of organizations also use tools like Alteryx, SageMaker, Azure ML, and those work fine as well. The data scientists, they're using like Jupyter, Zeppelin notebooks. All this works with Snowflake, and you can use Python and R. Basically sky's the limit for how you can connect and interact with this data. So what this slide here is basically showing is where the workload is occurring. And basically on the left-hand side is basically the feature engineering. So when you have to clean up and modify your data to build a model, this is like 80% of where data scientists spend their time. And basically all that can be pushed and run within Snowflake. And that's quite helpful. If you have a lot of data, you can use the massive horsepower and the speed, and this is where all your data is, because it's a good data lake, it's a good data warehouse, so all your data is there anyway, and it's pretty easy to manipulate and do your feature engineering there. Currently, basically all the tools would do all the training in the tool rather than inside of Snowflake. So basically, when you do the serious calculations, all the real number crunching to produce a model, that's actually occurring within the tool. Once you have the model ready, then you have two options. You can either host that model in your tool or in a cloud wherever, or on premise, wherever you want to host your model. You do have an option of hosting that model within Snowflake. So using our Java UDFs, if you save your model as a Java jar file, then you can upload it into Snowflake and leverage right there. You can score a massive amount of data right through that model within Snowflake without pulling any data out, and it performs extremely efficiently. This is just a single screen snapshot of DataIQ, and as you can see, it just is an example of how one of the citizen data science sort of tools interacts with Snowflake, is that as you move through the stages to clean up and join and manipulate your data and do your feature engineering, and then even creating models and then scoring your models into a final data set that has all your predictions applied, each of those blue boxes is a Snowflake table. So this is a pretty cool thing that for one, the performance is good, but secondly, now your data engineers can work together with your data scientists. Your data scientists are on the identical platform as your Power BI and Tableau type of developers and all your other BI sort of users. So finally, they can all really start working together. It's easy for them to share tables, within the data warehouse or data lake, and vice versa. Data scientists, easy for them to share backwards to the rest of the organization. And lastly, one of the key things I want to show is talking about governance and security. I'm not going to cover all the security options, but a lot of organizations are deeply concerned about governing data, of knowing where their private, sensitive customer or patient data is, being able to find where it is, making sure it's not in their dev environments to automatically search for that. If they find any, they want mechanisms to control who has access and to be able to anonymize it, to apply tokens, apply masking. If there's ever any leak of any data that someone maliciously let data out, then Snowflake has all these features where on that right-hand side you can trace back and see who's run any query, what was the IP address, what was the user, the role, and such. So we have a whole bunch of governance capabilities built in to Snowflake. And the cool thing is it isn't just for the data warehouse. A lot of organizations have been doing that type of stuff for 10 plus years in their data warehouse. But because we're the single platform that works across every single use case, we don't have a big, huge gaping hole in our security and governance sort of posture where, the data lake or the data science space is a total free for all, where people just kind of get all access to all data. So with that, that's basically the quick look at Snowflake. And what all this means is that we've gone from this sort of situation to a situation where each of those pain points has been improved. And look, in summary, this is just a really super quick taste. Be happy to share more information in Q&A, or feel free to reach out if you have any other questions. Thank you.